So here we'll be introducing with the topic of quadratic equations. So any second degree polynomial in a variable x when equated to 0 is a quadratic equation. So let's take a general form of that. So any second degree polynomial, that is some coefficient a x square plus bx plus c when equated to 0. So this is a general form of a quadratic equation. Now note that if the coefficient of x square is equal to 0, then it reduces to a linear equation. So if a x square is equal to 0, then it reduces to bx plus c equal to 0. This is a linear equation because there is only the highest power of x is 1. We need the power of highest power of x to be 2 for being a quadratic equation. Therefore, for quadratic equation to hold, a should not be equal to 0. Now, as it is a second degree polynomial, there are certain roots of this particular equation. So, roots of an equation. Values of y, so values of x, in fact, that is a variable. Values of x that satisfies the quadratic equation. Now what does this mean? This means that ax square plus bx plus c equal to 0. Here a, b and c are coefficients. They are constants. So for some particular values of x, this whole equation should be equal to 0. Those values of x are called the roots of the quadratic equation. So now in the next two lectures, we'll be looking at how do we find the roots of quadratic equations.